Welcome, guys, to another teaching session, and today we are going to be looking at the chain rule. This is also one of the ways of finding a derivative of a function when you are to apply using this rule called chain rule. So basically the chain rule, what it says is, and you're going to see by the examples as we go about it, it involves you letting one of the functions into a u such that it gives you a function of u. So if you look at how the chain rule applies, at the end of the day, it must look as if the du are cancelling each other such that you have dy over dx. But I know that is not necessarily mathematically true, but the essence of it is that when you eventually apply the chain rule, is you must have the derivative of that function with respect to u multiplied by that same function of u with respect to x, and then that will give you the final derivative of the question. So let's look at this example on finding the derivative of this question. So you are given y equal to the square root of x squared plus 1. So the question is asking you to find the derivative of this function. Now, we know if we were to solve this expression, it will become impossible, or not impossible, but it will become difficult for us to either use the multiplication rule or use the direct derivative. So the best way of dealing with this question is by applying the chain rule. Now, how do we go about getting the chain rule, applying the chain rule of this function? We must then change this expression underneath the square root into a function of u such that we can be able to differentiate that function and then find the derivative of the square root of u. We know that will be easy to differentiate using the direct derivative, and different to if you were to deal with it as a function. So that's the essence of letting. When you let, you are compressing a complex expression into one function such that you can be able to simplify that function. So in other words, in this instance, we need to let u equal to x squared plus 1. Now that we have let u to be this function, let's find the derivative of that function of u with respect to x. What will be the derivative of u, the derivative of this function with respect to x? We bring down, because we're focusing on x, we bring down the 2 down here, it will become 2. Subtract minus 1, then it will become 2x. Now that we have found du dx, remember we need to apply this chain rule method. Now we have found du dx. Now we must find dy du. How do we find dy du? We go back to this function y. In the place of u, we said we are letting x squared plus 1 to be u. It means in the place of x squared plus 1, we put a u. That means here we'll have the square root of u. Now, another way of writing the square root of a number is the same as u, because the number here is 2, is the same as u 1 over 2. Now, if we are given like this, we are able to differentiate, because dy du, remember now, we are looking for dy du. How do we differentiate this? We bring down the half. So we will have half u, we subtract a 1, which will then becomes minus 1 over 2. Because half minus 1 is minus half, which means the final answer then will be 1 over 2. Because it's a negative exponent, applying the law of exponents, if you have a negative exponent, you must put it underneath 1. Everything put it underneath 1, but change the sign into a positive sign. In other words, this will be the same as 1 over 2 multiplied by 1 over u to the half. Or you can write this as, you can multiply them out, 1 times 1, which is 1, 2 times u to the power half, which will be 2u half. Or you can write it as 1 over 2 square root of u. Now that's the derivative of dy du. Now when we apply the chain rule, it says dy dx, it's equal to dy du times du dx. Now what is dy du? dy du is what we found here, dy du, which is 1 over 2 square root of u times what is du dx? du dx, which is equal to 2x. Now you can see this is the same as 2x over 1, which means this 2 and this 2 can cancel out, which then gives you x over square root of u. But remember, our question did not start with u. We were finding the derivative of a function of x with respect to, so we're finding the derivative of the function of y with respect to x. We did not have any u in our question. So it means we must bring back what we have said we let u to be. In other words, the final answer becomes x over square root of, in the place of u, we put what we let in here, which will be x squared plus 1. That becomes your answer of this question. Let me hear your comments or inputs on any other ways in which you could have done this question applying the chain rule. Thank you.